Alright, let's see what we have here. For each pair of lines, decide if you think they look parallel, perpendicular, or neither. Then use the slope formula to find the slope of each line. What do you notice? Alright, well, let's, look at problem number 1. Do these seem parallel, perpendicular, or neither to you? Do you understand what that word means? I'm hoping looking at number 1, you're thinking, yeah, that looks parallel. What about number 2? Are these, okay, back to parallel. Parallel is where the lines are equally steep, and these lines will never touch. Even though they truly extend forever, no matter how far they go, they will never meet. That's what parallel is. Clearly these lines meet, so they're not parallel. But are they perpendicular, or are they neither? Okay, I'm hoping you can see that these two lines are neither parallel nor perpendicular. Perpendicular means that they have to meet at a 90-degree angle. So for example, if you take a square or a rectangle, if these are truly 90 degrees, then I should be able to perfectly fit the corner of a square or a rectangle in here, and it would fit perfectly. As you can see, I have extra space on the above and below, so this is much wider than 90 degrees, so there's no way that that is perpendicular. Okay, so that's going to be neither. What about number 3? Parallel, perpendicular, or neither? Yeah, that's looking perpendicular to me. Okay, that's really messy handwriting, but it's looking perpendicular. I'm thinking if I angle this square just right, and that's hard to accomplish, but as you can see, it's pretty close. Okay, that's pretty close to 90 degrees, and this is tough to adjust, but if I were able to rotate it just right, I think it would fit perfectly. So that appears to be perpendicular. What about number 4? Okay, again, it looks perpendicular to me. Maybe I'll squeeze it in up here, perpendicular. Okay, what else we got? Number 5. That looks like neither to me. Number 6 appears to be parallel. Okay, again, number 5. I'm going for neither because if I take my handy dandy square and try to fit it, it does not seem to match the 90-degree shape of a square. Whereas this one, again, is pretty good. Whoa, too far. Alright, it's hard to angle it just right, but you get the idea. It's pretty darn close. Anyway, okay, I think I'm done with that anyway. So, hopefully you get the general idea of what parallel looks like, what perpendicular looks like. All right, it's got to be 90 degrees. Normally when it's perpendicular, we write a little box right here to show, like this should make a little square when I put it in here. Okay, to show that, yeah, that's 90 degrees. Alright, now, so we did the first part. Do we think it's parallel, perpendicular, or neither? Now we got to do the second part. Use the slope formula to find the slope of each line. Okay, so let's find the slope of each red line, and then we'll find the slope of each blue line. So we'll have red. Okay, maybe I'll just. Alright, so I've color coordinated this to make it easy to follow. So we'll put the slope of the red line here, and we'll put the slope of the blue line here. Let's start with the red line. When you look at a line on a graph, you should scan the line looking for points where the line crosses evenly where grid lines meet. For example, here, 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 and here. These are all the points along the red line where the line crosses right where the grid lines meet. So these are useful points because they don't involve decimals. Now, if we're going to do this the way the instructions say, it says to use slope formula, then the idea would be to pick 2 points and do y minus y over x minus x, because that is the slope formula. Is like, you know, y2 minus y1 over x2 minus x1. So you could really pick any 2 points you want. So the points I'm going to pick are going to be random, but let's see, I'll use this point, the y-intercept, just for fun. So this is the point 0, 5. So I'll use that for one of my points. I don't know. I'll use this point right here. This is the point 4, 3. So 4, 3. So I could pick these 2 points. I could do the slope formula, and that would tell me the slope of this line. So that's going to be. It really doesn't matter what order which one I see as y1 and which one is x1. It's your choice. Just do it the same way both times. So I'm going to go ahead and do 5 minus 3 for my y minus y. And then I have to do 0 minus 4. I've got to do it the same way twice. So that's going to give me 2 over negative 4. And then I've got to reduce that. Oh, too far. So that's going to reduce down to negative 1/2. Okay? So that is the slope of the red line. Let's go ahead and put that on the line. So negative 1/2 is the slope of the red line. So that was the idea. Now, having said that, I want to point out another way to find the slope of a line. And what I'm about to say is actually the way that I do it. If somebody just showed me this graph and asked me to find the slope of the line, I would not pick 2 points and do the slope formula. We all know that slope is rise over run. Okay, because we learned that in middle school. So I would still use these points that are here, the points where it meets the grid lines. But I would travel from point to point doing rise and then run, and then that way I will see what the rise and run is. So as I travel from point to point, I'm doing this. Down 1 over 2. Negative 1, positive 2. Down 1 over 2. Negative 1, positive 2. That's the rise over run. So looking at the rise over run, it's negative 1 over positive 2. So I can just at a glance tell what the slope is based on the rise and the run. Make sure you do the vertical and then the horizontal, the rise and the run. So within 2 seconds, I can tell you what the slope is, negative 1 over 2, which is the same thing we got using the slope formula. Okay, so I encourage you to use the rise and run if you understand it. Now, for whatever reason, a lot of kids have trouble with that. They just don't see it very well. So I think it's just a matter of if you're a visual thinker or if you're more comfortable with formulas and numbers. I'm a very visual thinker, so going rise and run is very comfortable for me, but that might not be true for everybody. So you decide what works best for you. Anyway, let's accelerate and do the blue line now. Again, it is helpful to start by looking at points where it meets the grid line like these. Okay, and again, I could pick 2 points and do the slope formula the way we were told in the directions. So I could pick this point right here, for example, and that point is the point 0, comma, -1. And then I'm just going to pick this point right here, okay, which is the point 2, comma, -2. Okay, so when I go to do my slope, y minus y, I'm going to do -2 minus -1. So that would be -2 plus 1. So I'm doing bottom minus top, so I have to do bottom minus top again, so 2 minus 0. So -2 plus 1 is -1. 2 minus 0 is 2. So look at that. Once again, we get the slope of -1/2. So -1/2, -1/2. Alright, so in this case the lines were parallel, and when we did the math, the slopes came out to be the same thing. We'll have to continue on and see if that will always be true. But again, notice I could, if you're a visual thinker, you might just look at this and do rise over run. Down 1 over 2. -1, +2. Down 1 over 2. -1, +2. And that would give you your -1, +2. Okay, let's look at problem number 2. Alright, this one was a neither parallel nor perpendicular. Let's see what happens. Let's do the red first. Just picking a couple points off here. Okay, let's see. Alright, so here's some points here, for example. While I'm at it, let me go ahead and mark some of these blue points too. Alright, so here are some points I could use. So for the red line, I'm going to use the y-intercept again. So that would be the point 0, comma, -3. And then I'm going to go ahead and use, this point. You know what, I'll just use the next one in a row. So this is the point 1, comma, -5. So if I do the slope formula, y minus y. So this time I'll just do top minus bottom. So y minus y would be -3 plus 5, because of the minus and negative, and then 0 minus 1. -3 plus 5 is 2. 0 minus 1 is -1. So that's going to give me -2. Okay, 2 divided by -1 is -2. So that is the slope of the red line. Let's go ahead and put that on the line. Okay, so that's -2. Now the slope for the blue line. Say if I were going to do this the visual way, instead of using the instead of picking 2 points. This one would have been down 2, right 1, -2, +1. So looking at it that way, -2 over +1, that's still going to give me a result of -2, same slope. So just another way to think about it. Alright, now looking at the let's look at the blue line now. Alright, let's say I pick the points 0, 4 and 1, 6, these 2 points right here. If I do top minus bottom, that gives me 6 minus 4 and 1 minus 0, like this. So 6 minus 4 is 2, 1 minus 0 is 1, and that's going to give me positive 2. Alright, so I have a slope of positive 2 and negative 2, and we decided that those are neither parallel nor perpendicular. Okay, let's keep going. Okay, so number 3. Alright, these blue points are the points that I see where the red line meets evenly at the grid lines. How about the blue? Okay, so these are the points where the blue line seems to hit evenly at grid lines. But of course we're going to do the red first. Let's say if we pick these 2 points, 0, 7 and 2, 4. So the slope would be 7 minus 4 over 0 minus 2. 7 minus 4 is 3. 0 minus 2 is negative 2. Now let me make something clear to you. The following 3 things are all equivalent. 3 over negative 2 is the same thing as negative 3 over positive 2, which is the same thing as having the negative sign right in the middle. Negative 3 over 2. So I need you guys to understand that when you're dealing with a fraction and a negative sign, these 3 things are all equivalent. So if you see one line that has a slope of 3 over negative 2 and another line that has a slope of negative 3 over positive 2, well, both of those are negative 3 over 2. They're the same thing. On the other hand, please understand that if you ever saw this, negative 3 over negative 2, if you were doing the calculations and you came up with this, I'm hoping that you would not leave it like this. Because what is this really equivalent to if I simplified it? This would be equivalent to positive 3 over positive 2. Okay, a negative divided by a negative is a positive. So some kids think that if the negative is in the middle, then that's the same thing as having negative 3 and negative 2. But it's not. If the negative's in the middle, that's like having the negative in the top or the bottom, but not both. Okay, so the slope of the red line is negative 3 over 2. Now let's do the blue line. Okay, I'm going to go ahead and use these 2 points right here. I'm going to do top minus bottom. So this blue slope is going to look like this. 1 minus negative 1, so that's 1 plus 1, over 0 minus negative 3, so that's 0 plus 3. So that's going to give me 2 over 3. Okay, now keep in mind that we decided that these lines were perpendicular. Negative 3 over 2 and 2 over 3. Is there a pattern here that we can nail down? Now, one more time, if I wanted to know the slope of these 2 lines without doing these calculations, here's what I would have done. For this red line, I would have gone like this. From one point to another, this is going down 3, right 2. That's negative 3 over positive 2. So I would have had negative 3 over positive 2, which is negative 3 over 2. For the blue line, because I'm always trying to do rise and then run. So for the blue line, I would have done up 2, right 3. That's positive 2 positive 3. So that would have looked like this, positive 2 over positive 3. So either way I would have gotten the same slope as we did by the calculations, negative 3 over 2 and positive 2 over 3. Okay, looking at problem number 4, these blue points represent the points where the red line hits evenly on the grid lines. I'm going to go ahead and do the slope this time using the rise and run method instead of picking points and doing the calculations. So, but you can do what we've been doing. You can pick the points and do the calculations if that's easier for you. But rise and run from one point to the next. The rise is down 2, the run is right 1. So negative 2, positive 1, negative 2, positive 1. So the slope for the red line is negative 2 over positive 1, which is simply negative 2. Now let's do the blue line. These are the points where the blue line hits the grid evenly, and again using the rise over run method, it seems to be up 1, right 2, positive 1, positive 2, positive 1, positive 2. So that would be positive 1 over positive 2, rise over run. Well, there's nothing to do, okay? So we have negative 2 over 1, which is negative 2, and we have positive 1 over 2. Okay, negative 2 over 1, positive 1 over 2. Let's do number 5. Alright, I want you to pause the tape right now for a minute, and especially if you have not already done this by yourself. I want you to pause the tape and find the slope of the red line and the slope of the blue line by yourself. Don't just watch me do it and copy it down. You know who you are. That's not helping you learn, so quit it. Pause the tape and find the two slopes yourself, and then start the tape and see if you got it right. That's how you learn. I'll wait. Okay, I hope you took my advice. Otherwise, you deserve what you get.
Daddy, we gotta go.
Okay. That's my kid. Time to go to soccer practice. To be continued. Pause the tape. Alright, let's find the slope of the red line. It's down 3, right 1. That's negative 3, positive 1. Okay, so the red slope is negative 3 over positive 1, which of course would simplify to negative 3. Now let's do the blue line. It is going up 1, right 1. Positive 1 over positive 1. So that's positive 1 over positive 1, which equals, of course, positive 1. Okay, so the blue slope is positive 1, the red slope is negative 3. Interesting. Very, very interesting. Now, look at the pattern. We're trying to see if there's a pattern we can observe. Number 6, let's do the red line. We have points here, 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 and here. Alright, rise over run. Up 3, right 1. Up 3, right 1. Up 3, right 1. That's positive 3 over positive 1, which of course would reduce to 3. Now let's do the blue line. Up 3, right 1. Positive 3 over positive 1. Up 3, right 1. Positive 3, positive 1. Were these parallel lines? Interesting. They both reduce to 3 and 3. That's parallel lines. Let's see if we can begin to observe these patterns. Okay, so fine. The blue line was slope 3, and the red line also had slope 3. Alright, so now we are at the final and most important part of this lesson. It's time for us to begin to observe the patterns and see what's going on. Let's start with parallel lines. But the idea is to find out, is there a pattern that we can see between all parallel lines and their slopes? So if we look at problem number 1, we had slopes, they were parallel, we had slopes -1/2 and -1/2. Okay, so those slopes are the same. Will that always happen? Let's look at problem number 6. Also parallel lines, slopes are 3 for the red line and 3 for the blue line. So again, parallel lines, same slope. Parallel, -1/2, -1/2. Okay, so I think we've got a pattern here that we can observe. It seems like anytime lines are parallel, their slopes will be exactly the same, like -1/2 and -1/2, 3 and 3. Okay, so I think we will let's stop and think about that for a second. Remember that slopes are either uphill or downhill, so let's see if this makes sense. Looking at this blue line, for example, you see how it's going downhill and the red is also going downhill. That makes sense because slope tells you how steep the line is, and if two lines are parallel, they're going to be equally steep. So it makes sense that their slopes are going to be the same number. It also makes sense that since they're both going downhill, the signs will be the same. So it makes sense that the blue line is going to have the same slope as the red line, since they have the same steepness and they are both going downhill. Okay. On the other hand, looking at number 2, see how the red line is going downhill, and it had a negative slope, but at the same time the blue line was going uphill and it had a positive slope. So there's no way that those were going to be parallel. Okay, let's look at a way of writing down what we just discovered. We could say parallel lines, the slopes of parallel lines are the same, or we could have said equal. Alright, now let's go ahead and look at perpendicular next, because when it's time to talk about neither, that'll just be sort of a none of the above. So look here. First of all, let's look at the signs. This one has a negative slope, -3/2. This one has a positive slope, +2/3. Is there a pattern here? Look at number 4, negative slope on the red line, positive slope on the blue line. Are there any others? No, I guess these are the only two we have to look at. But notice, negative slope and a positive slope. Okay, now let's think about why that makes sense. Why would that be? If you look at the blue line, for example, that's going uphill. That's going to be a positive slope. Red line's going downhill, negative slope. It makes sense that any time you have perpendicular lines, you're going to have one going uphill and you're going to have one going downhill. So it makes sense that you're always going to have a positive slope and a negative slope whenever two lines are perpendicular. Okay, blue is positive, the red is negative, uphill, downhill. That will happen every single time. So now what else is going on here other than the signs? 3/2, 2/3. How would you describe that relationship between 3/2, compared with 2 over 3. There's a word for that. What's that called? Can anyone remember? 3 over 2, 2 over 3. Starts with an R. Okay? The word is reciprocal. Alright? So not only are they opposite in sign, but these two fractions are reciprocal. 3 over 2 and 2 over 3. Okay? Those two lines, when the fractions are upside down from each other, they're called reciprocal. Now, will that always happen when we have perpendicular lines? Well, let's look at number 4. We have -2 for the one slope, and then we have 1/2. Are those reciprocal? Well, I purposefully left it as 2 over 1 for a moment, ignoring the sign. It's 2 over 1. Okay, if we do the reciprocal of 2 over 1, what are we going to get? 1 over 2. So yes, those are reciprocal. Okay, so if you see a slope of -2, please understand that that's the same thing as -2 over 1, and the reciprocal would be 1 over 2. So don't be fooled by the fact that there's no 1 under it. There's always a 1 under it. So 2 over 1, 1 over 2. So it's time to generalize and write that as a general statement. Remember, for perpendicular lines, there were two things that were happening. It seems like they always had opposite sign. One positive and one negative. And they were always reciprocal. Reciprocal. That meant the fractions were upside down when you compared one to the other. So, in the case of parallel lines, from now on we will know that the slopes will always be the same, like 3 and 3. For perpendicular lines, the slopes will be always opposite in sign and reciprocal. Like one's positive and one's negative, and they will be upside down from each other. Alright, let's look back at these cases that were neither parallel nor perpendicular. Alright, like these slopes are opposite in sign. One's positive and one's negative, but yet they're not perpendicular. I mean, they're obviously not parallel because they're not the same, but why are they not perpendicular? You know, they're opposite, so what's missing? Well, remember, perpendicular lines are supposed to be opposite, but they're also supposed to be reciprocal. Now, what would that look like? 1 over 2. 2 over 1, 1 over 2. Okay? But since it wasn't 1 over 2, that's a neither. Let's look at the other one that was neither. Again, they have opposite sign. One of them, the blue one here is positive, and the red one is negative. Obviously, they're not the same, so they're not going to be parallel, but they are not going to be perpendicular either, because not only do they have to be opposite in sign, they must be reciprocal. For example, if this is -3 over 1, the blue one would have to be 1 over 3. Now those are reciprocals of each other, 3 over 1 and 1 over 3. But since that didn't happen, then it's a neither. Alright, now we're on the back of the page, and we're going to use what we just learned about perpendicular lines for number 7 and 8. So look, when we talk about the distance from a point to a line, we are always talking about the perpendicular distance. That's very important. Now, remember what we just talked about when we talked about lines that were perpendicular. So when you see perpendicular, you should be thinking that the slopes are going to be opposite sign and reciprocal. Alright, please keep that in mind. So if I want to very carefully draw a perpendicular line, am I going to draw a line straight down to 3 over 2? Is that going to be perpendicular from this point to the line? Will it be perpendicular if I draw a line to the 6, 5? Well, if we really want to be careful about it, we will look at the slope of the line that we have. So the slope of this line, remember, for me, I like to get it by just doing rise over run. So this line goes up 1, right 1, rise 1, run 1. So this slope is 1. Whoops, why did I put 2? This slope is 1 over 1. Okay? Which of course normally we would just put 1. Now a perpendicular line is going to have a slope that is opposite sign and reciprocal. So that since this is positive, a perpendicular line should be a negative slope. And but the reciprocal of 1 over 1 is still 1 over 1. Okay, so the original slope is positive 1 over 1, but we're about to draw a perpendicular line. So we're going to make sure that the slope is negative 1 over 1. That means down 1, right 1. So starting from this point, I'm trying to get to this line, but I will get there by going down 1, right 1, down 1, right 1, down 1, right 1. Okay? So if I want my line to be perpendicular, and that's what it means to be the distance from a point to the line, I would draw this segment. Okay? That is the perpendicular distance. That is the distance to the line from 3,8 to 6,5. So of course then I could go ahead and do the distance formula to find that distance. Okay, so the setup for the distance formula between 3,8 and 6,5 would look like this, and that turns out to be 3 radical 2, which as a decimal is approximately equal to 4.2. Okay, so that's the distance from the point to the line. Now let's do the same thing for number 8. Please pause the recording and do number 8 by yourself. Don't just watch me do it a second time. Pause the tape now. I'll wait. Okay, hopefully, if you know what's good for you, you paused the tape and did it yourself, and now you're just checking your answer. Otherwise, if you get this wrong on that test or quiz or whatever, that's on you for not following the Burton system. What was I saying? Oh yes. How far are you from Fifth Avenue? Well, here's you, here's Fifth Avenue. You are a point, Fifth Avenue is a line. So the distance to Fifth Avenue has to be a perpendicular distance. So once again, let us talk about rise over run, which for me is the easiest way to find the slope. So here are some additional points that hit right on the grid lines. I always like to do rise first and then run, because that's the order we put the fraction, is rise over run. So from point to point, the rise over run is down 1, right 2. That's negative 1, positive 2. Negative 1, positive 2. Negative 1, positive 2. Okay, so the slope, I'll put it over here. So the slope of the original line is negative 1 over positive 2. Now we need the slope of a perpendicular line would be positive something. Okay, so that would be positive 2 over 1 if I do the reciprocal. So that would be, again, if I sort of simplified it, negative 1/2, which is perpendicular to a line with slope positive 2. But I'm going to look at this one when I do the line. I'm going to make sure I go up 2 and right 1. Okay, so here's a couple ways to look at it. If I started from this point and I just said I'm going to go up 2, right 1, this is what that would look like. Up 2, right 1, up 2, right 1. I'd have these points forming, but my line is sort of going in the opposite direction. I know I need to get towards Fifth Avenue. So, but once I have a couple points down, I can follow the pattern in the other direction by going down to left 1, down to left 1, down to left 1. So this would be the point that I would hit, Fifth Avenue. Okay? So, as far as the distance that we're talking about, here's you, here's Fifth Avenue. This would be the perpendicular distance that we're talking about. Alright, that is the distance right there. So the question is, what is that distance? So we could do the distance formula, or we could do a tiny little Pythagorean theorem. I'm just going to do the distance formula, so hopefully you won't get too confused. The point where you are standing is the point 5, 4. The point where you meet Fifth Avenue is the point 4, 2. Okay, so we could just do the distance formula between those 2 points. That would look like this, and I'm getting the square root of 5, which is approximately equal to 2.2. Okay, so that is the distance from you to Fifth Avenue. Look, I mentioned that we could do the Pythagorean theorem. Let me show you that real quick. Okay, here's you, here's Fifth Avenue. Now, if we do that rise over run type of thing here, like this, okay, you see that what we have here is a tiny little right triangle. And the distance that we're trying to find is the hypotenuse of the triangle. So this rise over run forms the legs of the triangle. So this rise here is 2 squares tall. Okay, so that side of the triangle is 2, and this side of the right triangle is 1. So we're trying to find this hypotenuse d. So if we do the Pythagorean theorem, you know, a squared plus b squared equals c squared, then that would make this 2 squared plus 1 squared is equal to the distance squared. So that's just going to be 4 plus 1 is equal to the distance squared. So that's going to be 5 is equal to the distance squared. And then of course I'm just going to take the square root of that. So the square root of both sides. So that is what is giving me that the distance is the square root of 5, which as a decimal turns out to be 2.2. Okay, so please understand that the distance formula is the same thing as the Pythagorean theorem. It's just right about at this point, for the distance formula, they immediately put the square root over it all. But this 2 comes from doing, you know, in this case, y minus y, and this 1 comes from doing x minus x. Anyway, just multiple ways to think about it. Now look, line A has a slope of 1/2. Okay, I'm just going to temporarily draw this. Okay, so here's line A. Okay, line A has a slope of 1/2, let's say. Line B is parallel to line A. So let's do one that's parallel. Okay, so this is line A, and this is line B. Let's go ahead and do this right now. If line A has a slope of 1/2, guess what the slope of line B is going to be? Well, the slope of line B is also going to be 1/2. Okay, on the other page, we just learned or reinforced that the slopes of parallel lines are always the same. But that just makes sense with what we learned a long time ago about slope. Parallel lines are equally steep, so of course the slopes are the same. So what's the slope of line B? 1/2. Now, line C is perpendicular to line A. So let's get that done. Alright, so here's line C, which is perpendicular to line A. If the slope of line A is 1/2, what should the slope of line C be? Say it out loud. Well, what did we learn? If the lines are parallel, their slopes are the same. But if lines are perpendicular, the slope should be opposite sign. So since this one is positive, then this one should be negative. But it should also be reciprocal. So if this is 1/2, then that becomes 2/1, which is the same thing as simply -2. Okay, so if line A has slope of 1/2, if C is perpendicular, it will have slope -2. Okay, for these next ones, for 11 through 15, we're supposed to just find the slope of each line below. Okay, so if we want to find the slope of each one of these lines, of course, we're just doing, y2 minus y1 over x2 minus x1. Or you could do y1 minus y2 as long as you do x1 minus x2. Either way, just do it the same way both times. So let's say if we do that for 11 through 15 right now. Well, this is what we're going to end up with. We've got 3, -3, -1/3, 3, and -1/3. Now, in a minute, we're going to be asked about what lines are parallel, what lines are perpendicular, and neither. So let's just remember what we talked about. What would it take for lines to be parallel? Their slopes would have to be equal. So with that in mind, do you see any of these lines here that would be parallel? Look at number 13 and 15, F and H, -1/3 and -1/3. Those slopes are the same, exactly the same, so those would be parallel. So F and H would be parallel. Here, I'll just make a little note of that. Line F would be parallel to line H. That's the symbol for parallel, by the way. What else? Well, look at this one and this one. Okay, that's D and G. Again, they're exactly the same. So those are going to be parallel. So line D is going to be parallel to line G. Okay, so I think that's it for parallel. Now, what about perpendicular? Remember, for perpendicular, lines have to be opposite and reciprocal. The slopes have to be opposite and reciprocal. So, will D and E be perpendicular? 3 and -3? No, they're opposite, but they're not reciprocal. What about -3 and -1/3? Will those be perpendicular? No, they're reciprocal, but they're not opposite. They're both the same sign. So, here's an example of perpendicular. 3 and -1/3. Alright, those are opposite in sign and reciprocal. 3/1, 1/3. So, for example, line D and F would be perpendicular. So D is perpendicular to F. Anything else? Let's see. So we had 3. So 3 and -1/3. So I guess there's a bunch of these. So D and F would be perpendicular, and F and G would be perpendicular for the same reason. What about H? Okay, G and H, D and H. There's a lot of perpendicular. So let's go on and answer the actual question. So looking at number 16, D and E, are they parallel, perpendicular, or neither? Well, D and E, that's neither. They're not the same, and they're not reciprocal, so that's neither. What about number 17? G and F. G and F, they are opposite and reciprocal, so that's perpendicular. What about number 18? F and H. Of course, F and H are both exactly the same, negative 1/3 and negative 1/3. So F and H are parallel. And I think that's the end.